Hello everyone, welcome back to my channel. This is Data Structure MCQs Class 2 for UGC Net, SET and DL competitive exams. Okay, in today's session, we are going to solve the important MCQs with a deep concept. So let's start today's session. Question number 1. Suppose an edge of a connected graph G belongs to every spanning tree of G. Which statement is true? G is a tree with one of the vertices of that edges as the root. G is Hamiltonian. That edge is part of a critical path. Removing the edge makes G disconnected. So let's solve this carefully. First, we need to know about what is spanning tree. So its spanning tree connects the all vertices. We need to connect the all vertices. For example, here there are four vertices. There's there A, B, C, and D. We need to connect each and every all vertices. It contains no cycles. For example, if you started with A, again we are starting with B. This we call as a loops or cycle. So we don't have any cycles or loops in a spanning tree. It has exactly n minus 1 edges. How many edges are there? N minus 1 edges. For example, if what n is nothing but vertices. For example, there are four vertices are there. 4 minus 1. Then how many edges are there? 3 edges are there. Now the question says, what the question says? One edge belongs to every spanning tree. This means the edge is compulsory here. Okay. Here the edge is compulsory in a spanning tree. Without the edge, the graph cannot remain connected. If we remove the edge, the graph is disconnected. Okay. Such edge, this type of edge we call as a bridge edge or cut edge. Okay. If we remove the edge, the graph is disconnected. This type of edge we call as a bridge edge or cut edge. Okay. So here the definition bridge edge is an edge whose removal disconnects the graph. So let me explain with a small example. So here all about the spanning tree here. So there is one graph is there. How many vertices there? A, B, C and D. So if we remove B to D connection, the D become isolated. Okay. If we remove the B to D connection, the D should be isolated. There is no connection between A, B and C. Okay. So graph becomes disconnected. So, but that's why which option is correct? The option D is the correct answer. If you remove the edge, what will happen? The edge is disconnected. This is the correct answer. Okay. So here, this is the example of the spanning trees. So there are different types of spanning tree. This is spanning tree 1, spanning tree 2 and spanning tree. So what happens if you remove edge B to D? If you remove, there is no connection. The D should be isolated. If you remove the edge, the D should be disconnected. The one edge of graph is disconnected. So to connect the vertex D to the rest of the graph, we need to remain B to D is remains available. So any spanning tree must include B to D. So here we are included B to D. Here we are included B to D. Here we are included B to D along with the spanning tree. Okay. So since we are removing the edge B to D, so here we remove the edge B to D. It makes the graph is disconnected. So this edge we called as a bridge edge or cut edge. Such an edge must be part of every spanning tree. Okay. So therefore, the correct answer for this question is option number D. Removing the edge makes G disconnected. Okay. Moving to the next question. Question number 2. Time complexity of breadth first search is what? So here, what is the birth first string? There are two are there. V, number of vertices, and E is nothing but number of edges. So before solving, let's understand what is complexity. Okay, before that, first we need to understand what is complexity. Complexity, it measures the efficiency of algorithm. How that algorithm is working efficiently, how that performance is there efficiently. There are two main types of there in a complexity: time complexity and space complexity. Okay, in a complexity means what? How the algorithm is working efficiently. In that complexity, there are two types of there: time complexity and space complexity. Then what is the meaning of time complexity? The time complexity measures the execution growth with the input size. Okay, how much execution input size is taking. And space complexity, how much space memory is using. Space complexity is nothing but the how much memory it is using, how much time it is taking for the execution. That is time complexity and space complexity. So what is the BFS? The BFS, it the traverse the graph level by level. The BFS, it will traverse from level by. First we will go to the level 1, then again it is going to the level 2, then again it is going to the level. So like this it will traverse from one element to another element with the level by level. So it use which data type? The BFS, breadth first search, will use the Q data structure. In a BFS, we will use in a Q data structure. There are one more data structure is there, that is DFS, depth first search. For this, we will use the stack data structure. Okay, for the BFS, we will use Qs. For the DFS, we are using the stack data structure. So here complexity analysis. Here V is nothing but what? V is vertices and E is edges. Okay. So during BFS, we need to traverse each and every vertex visited once. We need to visit each and every vertex at once. That we called as order of V. Okay, and each edge is explored once. This we call as a edge. And for example, A, B is that. These we call as a vertices, and these we call as a edge. So what is that? Each vertex is visited once means that is order of V. Every edge is explored once means that is order of E. So if we combine these both, the order of V plus E. So the time complexity of birth first search is, what is that? Order of V plus E. Option A is correct. Imagine there are 5 vertices are there and there are 7 edges are 5 vertices and how many edges? 7 edges are there. 7 edges are there. BFS visit all 5 vertices and all 7 edges. So hence the order of V plus E is correct one. 5 plus 7, like that. The complexity of the breadth first search is order of V plus E. So why these other options are wrong? Option B, order of V. So it is visited only order of V? No, the BFS visited vertices as well as edges. So it here only vertices are there. So option 2 is wrong answer. And order of E. So only edges is visiting BFS? No, it is visit vertices and edges. So order of E is wrong. So the correct answer is A. Then moving to the next question. Question number 3. What does the following function do for a given linked list with first node has head. So here there is some code is there. We need to explain that code. Void function struct node head, it is nothing but the pointer. The linked list we are using the pointer concept. If head is equal to null, return function head moving to the this symbol we call as a forward. The head is forwarding to the next element. Print percentile d, head is forwarding to the data element. So it prints all nodes of linked list. It prints all nodes of linked list in reverse order. It will print alternate nodes of a linked list. It will print alternate nodes in a reverse order. Okay. So this question is based on a recursion in linked list. Okay. Na? This question is based on a recursion concept. Okay. This from the recursion. So here if head is equal to null, then return. What these statements means, it will stop the recursion at end of the list. So head is equal to null means there is no element to move to the next element. Then immediately we are using the return. It will means it will stop the recursion at the end of the list. The recursion will start from the end of the list. Then what is the recursion call? Function head to next. If the function first move to the last node. After return, they will give the function of head to forwarding to the next. Then the function first moves to the last node. Okay. Suppose there is a list is there 1, 2, 3, and 4. So recursive calls first it will calls the recursive function. So and next. So what is the first function call? The function will call function 1. Then it is moving to the next. Then what is the next element? 2. Then it will calls the function 2. Then again the function head to next. Then what is the next element? 3. So the function call 3. And what is the head next to the function? 4. So it will call the all function 1, function 2, function 3, function 4. Then what is the last one? It will call the function, the recursive call the function null. Okay. Then the printing happening while returning. So then we are return the recursive. So here returning the recursive, the printing will happens while returning. It is the backtracking. Here we are using the technique called backtracking. Okay, that backtracking. Therefore, here the what is the backtracking for this 1, 2, 3, 4, 4, 3, 2 and 1. So recursive calling is nothing but here returning means the reverse order is printing. You have to remember recursive, we are printing the recursive call return means here the printing will come in a reverse order. Reverse order. So, therefore, the reverse order is printing. So, the correct option is we print all nodes of linked list in a reverse order. So, what is the reverse order? 4, 3 and 2, 1. This is the correct option. So, here print all nodes of linked list. Yes, here printing it will print all nodes of linked list, but there is no reverse order here. Only the normal forward order is there. So, this is the wrong answer. Print alternate nodes of a linked list? No. Or no alternate. Here there is no skipping language is there. Directly we are moving head to the next. So this is also wrong answer. The prints alternate nodes in a reverse order. Yes, here we are using the prints alternate nodes in a reverse order. But which nodes? All nodes or alternate nodes? No, alternate nodes Reverse order is correct. There is no alternate nodes. We are printing all nodes in a reverse order. Okay. This is the option B is the correct answer. So one thing you need to remember in your exam trick, print after recursion is whenever the recursion is completed, then we are printing head to data that will give the output in a reverse order. Okay. Print after recursion is nothing but the reverse order. Okay. Moving to the next question. Question number 4. The collection of variables, possibly of different data types, connected in various arrays is called what? Data structure, identifier, data name, structure. The data structure means what? It is organizing or it is arranging in a data, arranging the data in a organized form that we call as a data structure. So data structure, it is the efficient storage is there in a data structure. The storage is efficient. Storage is efficient. It is easy to access. So if you are arranging in a sequence order, then we can access easily. Yes, easy access. And it is the better processing. So there are different types of examples are there in a data structures: arrays, linked list, trees, graphs, queues. So data structures main contents which type of data types? Integer, characters, pointers, arrays, and different data types together. So, the collection of variables possibly of different data types connected in various arrays is called a data structure. The correct answer is option A. So, why the option B is correct? The identifier means it is only a variable name. The variable name we call as a identifier. There is no organization is there here. The element organization is not there. Data name, it is not a technical term in a computer language, data name. So this is also wrong answer. So what is the structure? Structure is only one type of data structure. There are different types of structures are there, right? Arrays, linked list, graphs, queues, like structures. So structure is only a type of a data structure. This is not a data structure definition. Okay, the correct answer is option A. And question number 5. Let H be a subgroup of a group G. If H has index 2 in G, which of the following properties of H is always true and why? Okay. H is normal subgroup of G. Reasoning subgroups of index 2 are always normal. H is in abelian subgroup. Reasoning subgroups of index to inherit the commutativity. H contains all elements of order 2 in G. Reasoning elements of order 2 must lie in such groups. H is simple subgroup. Reasoning subgroups of small indexes are simple. Then what is the index means we need to know here. So what is the meaning of index? That index means here there are index, how many index are there? The index value is 2. Means there are only two cosets are exist. There is one important theorem is there. Every subgroup of index 2 is normal. Every subgroup of index 2 is normal. So index 2 is there means only there are two cosets are there for this index. Based on the theorem, what is the definition? Every subgroup of index 2 is normal. Okay. Subgroup of index 2 is always normal. So hence subgroup, here subgroup means normal. Then Left cosets is equal to right cosets. Yes, there are two cosets, left and right. If the subgroup is normal, then subgroups becomes normal. Then the left coset is equal to right coset. Then the correct answer for this question is option A. H is a normal subgroup of G. Why it is a normal subgroup of G? The subgroup of index 2 is always normal. How we are concluding this statement? With the help of a important theorem. There is one theorem is there. Based on the theorem, we are concluding this statement is correct. So why the option 2 is incorrect? Index 2 does not imply commutative. There is no commutativity is there. And there is no theorem. These elements of order to lie in a such subgroup. There is no theorem here. And simple subgroups are unrelated. No, simple subgroups are related. So this option is also correct. So one simple exam trick I need to tell. Index 2 subgroup means it is always normal. Index 2 subgroup means it is always normal. Next question. Question number 6. Every graph has only one minimum spanning tree. Okay. Every graph has only one minimum spanning tree. Is it true? True, false, nothing can be said, none of the mention. So minimum spanning tree means what? Just now we discussed minimum spanning tree. The spanning tree with minimum edge with their weight, the sum of weight. Okay, the sum of weight. Spanning tree with minimum edge with weight sum. So important point, a graph can have one minimum spanning tree, MST, minimum spanning tree, or multiple spanning tree also there. Why? Because multiple spannings are there. The edge weight is sum of the weights are there. So the edge is sum of weights. Then there is many multiple of MSTs are there. MST is nothing but minimum spanning tree. If edge weights repeat, multiple MST is possible. When the multiple minimum spanning tree is possible, if edge weights are repeated, the distinct edge weights means there is only one minimum spanning tree is there. There is only single edge, that is distinct edge is there. If there is only distinct edge, there is only how many spanning trees are there? Only unique minimum spanning tree is there. If the edge is repeated, if edge is repeated, then how many spanning trees are present? There are multiple spanning trees present. Then what the question they are asking? Every graph has only one minimum spanning tree? No, the answer is false. Based on the edges, based on the distinct edges or based on the repeated edges, we will state that minimum spanning tree, single minimum spanning tree or multiple minimum spanning tree. So there is no only one minimum spanning tree. So there is multiple minimum spannings are also there. Okay. Moving to the next question. Question number 7. Minimum, the given a connected graph G with vertices V and edges E. Graph G, the graph G with vertices V and edges E. A cut set is a set of edges whose removal disconnects the G. Which statement about the minimum cut set is true, and then what theorem is associated with? So what they are asking, there is one cut set is there. If we remove the disconnects the G, which statement about the minimum cut set is true? Here, which statement is true, and that how we are concluding that statement is true based on the which theorem they are asking. Okay, the minimum cut set equals the maximum flow theorem. The size of the maximum cut set is equal to the maximum flow. It is associated with the which theorem? max flow or min cut theorem. The size of the minimum cut set is equal to the number of vertices. It is associated with the Menger's theorem. The size of the minimum cut set is at least half the number of edges. It is associated with the edge cut lemma. The size of the minimum cut set is equal to the girth of the graph. It is associated with the gut cut theorem. Okay. So in flow network, maximum flow is equal to maximum transferable flow is that the flow is maximum, the transferables also there is a maximum. The maximum cut is there. Okay, maximum cut is there. The minimum edge is disconnecting the source and destination. Maximum flow is nothing but maximum transferable flow, and minimum cut is minimum edge is there. It is minimum cut is there and minimum edges are there. So important theorem, maximum flow is equal to minimum cut. Maximum flow is equal to minimum cut. So the option A is the correct answer for this question. The size of the minimum cut set is equal to the maximum flow, and this is associated with the max flow min cut theorem. Okay, so why the second option is incorrect? It is manager theorem. It is the discuss the connectivity. It is not disconnect. It is not discussing with the flow or minimum cut set. The Menger's theorem. It is discussing with the connectivity. Okay, there is. It is not discussing with the flowing. It is is the connectivity. Is discussing with the connectivity. So the size of the minimum cut set at least half of the number of edges associated with the edge cut lemma. It is also not a theorem. It is not a standard theorem. Associated with the gut cut, no such theorem is existed in our data structure. This is the wrong term. There is no existing theorem, gut cut theorem. So correct answer is option A. And simple remember thing, max flow is there, then it is the minimum cut. Okay. Whenever the max flow is there, immediately it is the minimum cut is there. Okay. Moving to the next question. Question number 8. In a binary search tree, each node has a unique value. If an inordered traversal else the sequence 1, 2, 3, 4, 5, 6, 7, which of the following sequence is possible pre-order traversals of the same tree? Okay. In our three concepts, there are three traversal techniques are there. Okay. There are three types of traversal techniques are there. Pre-order, in order and post order. Okay. To traverse in a tree from one node to another node, or one child to another child, or one parent to another child, we are using the techniques to call tree traversals. There are three types of tree traversals: pre-order, in-order and post-order. So here binary search tree property. So there is some rule is there for the binary search tree. So for example, if it is binary search, all the binary tree, the left subtree elements are smaller and the right subtree of the element is larger. There is one rule is there in a binary search tree to form the tree. If there is a root element is there in a binary tree, the left subtree or small elements are there. The right subtree is the larger elements are there. Let me take one example. For example, here I am taking the 50. Okay, this is my binary tree, and here there is some 20 is there. The node 20, and here 70 is there. So what is my root element? 50 is my root element. From the left side element is smaller and the right side element is greater than the root element. Okay, root element, less than elements are there from the root element is small element, greater element are there in a root element is writer, that is the larger. Okay, this is the example of the binary tree. So here, in order traversals of binary search tree is gives the sorted order. Every time the in order traversals of the binary search tree is always gives the sorted order. So if an in-order traversal, it is sorted in order only, right? 1, 2, 3, 4, 5, 6, 7 means every time the in-order traversal of the binary search tree, it will gives the which type of order? Sorted type of order. So we need to find out the possible pre-order traversal of the same tree. Okay, first pre-order means there is some rules are there for the tree traversals: pre-order, in order, and post order. So what is the rule for the pre-order? First we need to visit the root element, then we need to visit the left, then we need to visit the right. In order, first we need to visit the left element, left subtree, then root, okay. Pre-order means root, left, and right. In order means first we need to visit the left, then root, then right. And post order. Post order means first we need to visit the left, then right, then root. These are the rules for the tree travel sense. Now what they are asking, we need to perform the same tree in a pre-order. Okay, we need to perform the pre-order. So what is the rule for the pre-order? Which element we need to visit first? Root elements, root node. Okay, root, then left, then right. Okay, root, then right. So what is our elements? Here, what is the root element? So they are given already in order. In order means there are root element is there. So in for these in order, there are we need to remove. There are three elements are there. Left subtree. There three elements are there in a right subtree. So in means in which place the root element is present in a middle position. So what is our root element here? Our root element is 4. Our root element is 4. So first we need to visit our root element. Okay. Then what is our left side elements? 1, 2, 3. So for the pre-order it is 1, 2, 3. But what is the left side element here for in a pre-order? 4, 2, 1, 3. And what is the right side elements of the pre-order? 6, 5, and 7. So this is the perfect BST pre-order. Okay. 4, 2, 1, 3. So pre means what? Free. So it will matches which option here? First we are root element is there 4. Here there is the root element. No. B option is correct. C option is correct. And D option is correct. Based on the root element, we can identify the possible traversal tree. Okay. 4, 2, 1, 3, 6, 5, 7. This is the correct answer for the pre-order traversals for the same in-order traversal. So why this it represents the skewed traversal? It is not a pre-order traversal. So here what is option D? It is an a descending order. It is a invalid order is there here. Excuse me. So for the binary search tree, you need to remember one simple trick here. BST, binary search tree, is in order is always in a sorting order. If the elements are there in a sorting order, definitely you can choose the correct answer, that is in a in order traversal. Sorting order is there, that is in a in order traversals. Okay. Moving to the next question. Question number 9. Suppose you have a graph G with n vertices and m edges. If G is sparse and connected, which spanning tree algorithm is more efficient and what is the time complexity? And just now we discussed about the time complexity, right? The sparse graph means, okay, na? Sparse graph. Sparse graph means only there are fewer edges are there. Okay, na? Sparse graph means only fewer. Some edges are there in a graph. Okay, only fewer edges are there in a graph. Then the Kruskal's work efficiently. So here, Prim's algorithm with a binary heap, time complexity order of n plus n log n. Kruskal's algorithm with a disjoint set, data structure, time complexity is order of m log n. So here Kruskal works the efficient. So the correct answer is Kruskal algorithm. Why it is work efficiently? The Kruskal algorithm, it will sort the edges. Kruskal algorithm will sort the edges. It is used the disjoint sets. Okay, na? Disjoint sets is nothing but what? There is a unique edges are there, and it is avoid the cycles. Okay, it will avoid the cycles. It will avoid the cycles. So the Kruskal algorithm, what will do? It will remove the cycles or it will avoid the cycles. It is use the disjoint set and will sort the edges. So the complexity of these graph is order of n plus m. So efficient of sparse graph. The order of n plus m log n is the correct answer. So why the option A, the order of n plus m log n, it is the efficient but not best here. So it is also non efficient, but compared with the Prince algorithm, Kruskal's algorithm, order of m log n complexity is the efficient way. So in C, not preferred any answer generally. It is not a complete algorithm. So Prim's algorithm is an adjacent matrix. It gives order of n square. So there is no n plus or nm edges are there. So only n square is there. So this is also wrong answer. The correct answer for this is Kruskal algorithm with a disjoint set data structure. The time complexity is order of m log n. Okay. So simple thing you need to remember here. Whenever in a question, the sparse graph is there. Okay. Whenever they will ask the question in a sparse graph or sparse and connected graph, immediately you need to remember it is preferred to which one? It is preferred to the Kruskal's algorithm. Okay. And to the next question. Question number 11. Sorry, question number 10. Kruskal algorithm is used to. So just now we discussed about the Kruskal's algorithm. The Kruskal's algorithm is used to what? The Kruskal algorithm is used to, it will find the minimum spanning tree, it will find the single source shortest path, it will find all pair shortest path algorithm, and it will traverse the graph. The Kruskal algorithm is a greedy minimum spanning tree algorithm. We can say as it is a greedy greedy minimum spanning tree algorithm. So it will sort the edges. Just now we discussed Kruskal's algorithm. What it will done? It will remove the cycles and will sort the edges and will pick the minimum edge. Which minimum edge is there? We are traversing from that minimum edge and it will avoid the cycles. It is used for which one? It is used for the minimum spanning tree. It will pick the minimum edge is nothing there, right? That is minimum spanning tree. So hence the option A is the correct one. So why the option B is correct? The find the single source shortest path. It is not related to the Kruskal's algorithm. The find single source shortest path we are using for the Discustra. Okay, na? Discustra algorithm we are using. Okay. For the discussed algorithm, we are using the find single source shortest path. So option B is wrong. So what is find all pair shortest path algorithm? It is a very very important algorithm. So the find all pair shortest path algorithm for we will use the fluid partial fluid fluid partial algorithm and traverse the graph. We will use for the traversal graph. Which techniques we will use for to traverse the graph? BFS and DFS. Okay. Now moving to the next question. Question number 11. The postfix form of A multiplication B plus C divided by D is what? Sorry, modulus D is what? So in a expression evaluations, in a stack expression evaluations, there are three types of expressions evaluations are there. Infix, postfix, and prefix. Okay, infix, postfix, and prefix. There are three important expression evaluations are there. So here they given the postfix formation. We need to convert into the sorry. They given some expression. That expression we need to postfix. We need to convert it into the postfix expression. The postfix means what? The operator after the operands. Okay, na? So, for example, there is A plus B is there. Okay, here A means what? A is operand and B is also operand. And this plus is there, right? This plus be called as a operator. Okay, operator. Okay. A means A and B. If there is alphabets are there, that alphabets we call as operands. If there is and symbols are there like plus, multiplication, division, modulus, this we call as a operators. Okay. So simple I will explain. There is some expression is there A plus B. So first we'll discuss about the infix. It is there in a infix format. Why it is there in infix format? The operator is between the two operators, then we call as a infix. Then postfix, the operator is after the operands, that is postfix. And what is prefix? The operator is before the operands, that we call as a prefix. Okay. There are three formations are there: infix, postfix, and prefix. The operator is there between the two operators, that is infix expression. The operator is after the operands, that is postfix. The operator is before the operands, that is prefix. So now you know about the infix, postfix and prefix. So why what they are asking here, we need to change into these expressions into postfix. Postfix means what? The operators are before or after. The operator should be the after. So what is the for A and B, what is the postfix form? First two operands are there. Then what is the operator here? The multiplication is the operand. And for these expression, C and D is the operands. So what is the postfix? After the operands A, B, and this is the multiplication and this is the division. Then we need to combine A, B multiplication plus CD division. So here which option is correct? AB multiplication CD. Then what is the between operator is there here? Then it will come the after. The operator will come after. Then the correct option is answer B. Okay. So why this option A is correct? Incorrect operator placement. Here the division is there. This is the prefix. The operator is there in prefix. So the option A is incorrect. So what is option C? It is an infix. It is also some invalid operator of the prefix. And this everything should be an after. It is a wrong precedency. So every time we will follow the precedence. The precedence is most important to solve the expression evaluation. So how the expression evaluation? First we will solve the multiplication and division. First we will solve the multiplication, division, then we will solve the addition and subtraction. There is some precedence is there. First we will solve which one? Multiplication, division, then we will solve the addition, then we will solve the subtraction. This is the operator precedence we called. Okay. These questions are very, very important. Nowadays, in a set and net exams, they are asking about the expressions, changing prefix to postfix and postfix to infix, like that. They are asking. So, you need to remember the precedence rule. If you know the precedence rule and if you know the three types of simple rules, then you will give the correct answer. Okay. Moving to the next question. Question number 12. Prim's algorithm is also known as Discustra Squalton algorithm, Burbakas algorithm, Floyd Warshall algorithm, DJP algorithm. So the Prim's algorithm, here the correct answer is option D. The Prim's algorithm, it is a greedy minimum spanning tree algorithm. It is gradually expands the tree. Okay, na? Prim's algorithm, it will expand the tree and it is also referred in some books as a DJP algorithm. In some books, they are referring this Prim's algorithm is DJP algorithm. So, discussed algorithm is not a Prim's algorithm. It is a distributed system algorithm. Distributed system algorithm. And separate minimum span. This is the separate algorithm. And flood it is for the shortest. Just now we discussed all shortest path. The shortest path algorithm is Floyd Warshall algorithm. So here what is the correct answer? Prim's algorithm we also known as DJP algorithm. It is referred in some books. And question number 13. When the depth first search of a graph is unique, in our 10th question or 8th question, we discussed about the depth first search of all graphs. Yes, the depth first search, it will follow which data structure we will use for the stack data structure or queue data structure. The DFS we will use the stack data structures. For the BFS we will use the queues data structure. So it Depth first search we also call as DFS. Depth first search. So DFS depends on the starting node and adjacent nodes. Okay, it will depends on the starting nodes and the adjacent nodes. Okay, DFS it will from the starting node to and adjacent nodes. So it is changing the neighbor order, it will changes the DFS. If you change the neighbor, for example, there is A is there and D is there. So there are two vertices that way. So who is the neighbor of A? C. Okay, here one C is there. A to C and C to B is there. So what is the neighbor of A? The C is the neighbor of A vertices. So if you change the neighbor order, it will change the DFS. So DFS is generally is not a unique one. Okay, na? Generally it is not a unique one. If you change the neighborhood, the DFS will automatically change it. So it is not a unique one. Okay. So here therefore, when the graph is a binary tree, when the graph is a linked list, when the graph is a NRA tree, so here none of them mentioned. So DFS is not a unique tree. So it is when the graph is a binary tree means multiple traversals is possible, but DFS there is no multiple traversals are there. So question asks the graph DFS is generally. So there is no linked list is there in the graph. So the child order may vary. Then in array tree, there is some nodes, root nodes are there, but the child order are some different parts are there for the child end. So this is also wrong option. So the correct answer is when the depth first search of a graph is unique, no. When it is a binary tree, no. When it is a linked list, no. When it is an array, no. There is no unique keys there for the DFS. You need to remember there is no uniqueness is there in a DFS. If you change the neighborhood, the DFS will also be changed. Moving to the question number 14. What is the average complexity of the Wixod? So, did you get one idea, right? What is the complexity? There are two types of complexity out there. Time complexity and space complexity. The time complexity is whenever the input size is increased, how much time it is occupying. So, time is nothing but there is no seconds time. It is the operations executions like arrays, the loops, how much time it is taking to execute the loops. Like that, the time there is no second, there is no minutes time. Okay, and the space complexity, how much memory is occupying to execute the particular in data, that is nothing but the space complexity. So here what is the average case complexity of the quicksort? So it is quicksort. There is some important method is there for the quicksort. For the quicksort we will use the divide and conquer method. For the quicksort, which method we are using? Divide and conquer. So why this divide and conquer method? First we are dividing into the partitions. First we are dividing the array into two parts, that is the partitions. Then we will select the pivot element. Then we will find out the sorting. Okay, na? And this we call as a recursive sorting also. This we call as a recursive sorting. The balanced partitions give is the order of n log n. So what is the balanced partition? Each and every step there is a balanced partition is there. That balanced partition is there for the quicksort is order of n log n. Order of n log n. So this is the average case complexity of the quicksort order of n log n. So why the order of log n is too small. Some compared to the order of log n, the order of n log n some more larger. So this sorting needs only n operations? No, the sorting needs more operations. So here the logarithmic is came. But here there is no logarithmic. So this is not a correct option. The average case complexity is not the average case of the quicksort. The order of n square is the worst case complexity of the quicksort. The what is the, if the ask the question, what is the worst case complexity of quicksort is the order of n square. The quicksort average case is order of n log n. The worst case is order of n square. Okay. Now moving to the next question. Question number 15. What is the worst case complexity of bubble sort? The bubble sort will, how we will work the bubble sort? The bubble sort will repeat the comparisons. We are comparing the adjacent elements with the bubble sort. Yes. For example, there are four elements are there. 10, 2, 12 and 8. So we need to compare each and every element based on the comparison with the adjacent element. If it is smaller, then we are swapping to 10. If it is smaller, they are swapping with the 8. Again, we are swapping here. So 2, 8, 10 and 12. Like that we are comparing. So here there are sorting is working repeatedly. We were comparing the adjacent elements. Okay. So the worst case is what? The worst case is reverse the sorted array. Okay. The nested loops, it is executed the repeatedly. The operation becomes the n square. So the worst case complexity of the bubble sort is also n square, order of n square. So what is the worst case complexity of the quicksort? It is also order of n square. So bubble sort worst case is order of n square. Okay. Okay, that's all for today's data structures MCQs class 2. If you found this video helpful, like, share and subscribe to the channel. Thank you for watching.